what we discussed was we started with what blockchain essentially is, okay? And blockchain, in my simple terms, is like an immutable database, just to make it more and we're breaking everything down to the micro level so that it's easier and we get everybody on the same page, right? So I think you should move a little there so that the sun doesn't hit you a lot.
No, it's fine. It'll be more away.
Okay, so what we talked about was, like I said, blockchain. It's an immutable digital decentralized ledger technology that is, so data is stored in the form of blocks, and each block has the address of the previous block, which is why that's how they're connected in a chain, right? Now, one biggest myth that we broke was cryptocurrency is just a use case of this technology that we're talking about. Crypto is not the same as blockchain. It's blockchain is the foundational technology and cryptocurrency is the use case of blockchain. Bitcoin being the number, like the first cryptocurrency that came into the picture, right? And I'll give you an overview of that also, but we discussed the types or we discussed the use cases of blockchain and how blockchain would can be used in other spaces like supply chain management, or whether it is all the way from digital identity to NFTs. We talked about NFTs. I'm pretty sure you might have heard about NFTs, and we differentiated between like fungible tokens and non-fungible tokens, and what's the main difference, right? Now, fungible tokens are currency, Canadian dollars, whether it's any fiat currency or even cryptocurrency. The thing that can be replicated is a form of fungible token, and the non-fungibility in NFTs is basically it's a special it's a one of a kind asset. The biggest example that any NFT tutorial online would give you, like if you digitalize Mona Lisa, that's the kind of that's the technology that we're looking at. Now, we also talked about how the NFT bubble hit us in 2021, and the Bored Ape Yacht Club was a very big thing back in that time. But what other use cases of NFT that we can utilize, whether it was in terms of proof of ownership, luxury goods, or we even mentioned ordinals, which is sort of an NFT, but everything is on chain on the Bitcoin blockchain, right? Now, coming to Bitcoin specifically, it was obviously, everybody knows this, it was created by Satoshi Nakamoto, who then disappeared in 2011. We have no idea who he is. He still owns 22 million Bitcoin. No, sorry. How much?
21 million.
So sorry, 21 million is it's the max cap. And how much did he own? 22,000 Bitcoin. Yes. Guys, my caffeine is still hitting me, so do not hold me accountable. Okay, and
I forgot. I'm coming back.
yeah, that's all right. That's all right. So we discussed that, and then we moved on to talk about how proof of work protocol works. Now, this is something that I would definitely want to give you an overview, right? Where we talked about how just a basic insight on how the tech on the proof of work. I think it was here. Nope.
What is the space exploration thing?
I'll explain it to you. Just give me a second. Where is the other PDF? It's a very good example of how we're talking about, and that's where I will come back to it, but just a second. Yeah. So just to give you a quick brief for everybody that missed, right? This is brought to you by Starknet Foundation, and we're going to look at what Starknet does and stuff. But Starknet Foundation is basically a not-for-profit organization that works towards education and ecosystem development for the Starknet blockchain, basically. Now, Starknet is a roll-up of Ethereum, and we will talk about the difference between layer 2s and roll-ups that I researched yesterday to give you a better overview. But let me just move on to Bitcoin and Ethereum, where I talk about Bitcoin. So we talked about the genesis of Bitcoin. Are you guys able to see the screen? Right? Can you increase like the brightness or something like that?
Just fine.
Or it's just because of the sun?
Just fine.
Okay.
It's still, the 22,000 Bitcoin is worth $100 billion.
Yeah, it's more. This is a bit old presentation, but I think
And the second largest holder of Bitcoin now is Michael Saylor, right? Or is the ETF? They're like 4,000. Right? Something
No,
like
like Satoshi owns like 1 million, like estimate.
Oh,
22 BTC.
That's $1
Yeah.
billion.
The second
Yeah.
largest holder is BlackRock, is the ETF, right?
I'm not
Or it
sure.
could be
Maybe
Michael
the
Saylor now.
Yeah, I think it's Michael's. I'm not. Don't hold me accountable, but I think it's Michael Saylor.
He's at like 4,000?
Yeah.
66,000.
66,000? So it's
Yeah,
1
I
million?
saw yesterday, yeah. Michael Saylor's probably the-
66,000?
Yeah, he's a lot. He's in the
He's
Cuban.
just bad.
That's a few $100 billion.
Imagine he just converted his brain in 2000.
That's why people listen to all of his.
2017 he hard, and now he's got 66.
I know one guy who sold at $18,000.
I know a guy that looks just like you. I sold it to him for 400. And I know a guy who took it at 900 and died, but I know a 400 guy who took 60,000. He walked out. I gave him the cash. He walked out.
Okay, if I can just have your attention back to the overview. We were talking about Satoshi Nakamoto and how he communicated last in 2014 apparently to the updated information from Alvin. Now, what is Bitcoin originally trying to solve? And this is what we were looking at, and which, one of you just mentioned the parking was $11, right? And before it was 6. That's because of inflation and currency debasement, where currency debasement basically means the loss of purchasing power of a currency, and it's caused by excessive printing by the bank. The responsible party is the head of the central bank, and it causes affordability crisis, stock market bubble, and inflation, right? And we were looking how money was getting printed. Now, how is Bitcoin trying to solve this is through, in terms of Bitcoin, every 10 minutes a fixed amount of BTC is created, right? And these miners get rewarded each time they are able to mine a block. And the reward gets cut into half every 4 years, which is called the Bitcoin halving. Currently, the reward rate is 3.125 BTC. And this is just the supply of how BTC supply versus the current fiat money supply works.
What do you mean 3 point? How do they get that?
Who?
When they do the mining, they get.
Exactly. So when they do the mining, right, they get 3.125 BTC as a reward for each block that they mine. Now, how mining works, we'll look into that as well. But the current rate is 3.125. How did they get that? They initially started with 50 BTC per miner, and then every 4 years that becomes half. So it became 25, then it became 12.5, then it became 6.25. Now it is 3.125, and it's gonna get cut into half again in 2028 April, I think, approximately. That's
Everybody's in a rush to mine right now.
I mean, now that is also an issue, and the reason that this is called the network subsidy, right, is because now miners, when they initially started mining, they had this motivation of, or people that got into mining, they had the motivation of getting the reward rate or the reward money, right, that you are getting from mining a block. But because it is decreasing every 4 years, that is the reason we need to deal with the network subsidy, because if not many people are mining, then the protocol gets affected, and we're going to look into that also. I'm just going to quickly move forward and show you. Now, how does central bank enforce scarcity? Through obviously law. They're the ones that can only print money, and if you do print money, that's called fake money, and then you get they do it through violence. How is Bitcoin enforcing the scarcity? It's through code. So the protocol itself is designed to only mine a block in 8 to 12 minutes on an average of 10 minutes. If let's say a miner is able to mine a block in under 8 minutes, the protocol will increase the difficulty. If they are, let's say, able to mine a block over 12 minutes, right, it will decrease the difficulty. Now, we're going to talk about the proof of work consensus mechanism. Now, consensus mechanism is, what do you mean by consensus? Consensus means coming to a conclusion as everybody coming to a decision, right? Everybody coming to, everybody deciding and agreeing on one thing. So there are many types of consensus mechanisms, and we talked about two of them yesterday, proof of work and proof of stake. Just to explain to you what proof of work is, let's say I'm the protocol, you are the miner. Now, just to let you know, both the miner and the protocol are machines and not humans, but I'm just going to explain it to you as a human to human conversation, right? Let's say I'm the protocol and you are the machine, and you are the miner, and I'm going to tell you, I'm thinking of a number between 0 to 10. You can guess a number. Guess a number.
Okay, yes.
No, say the number.
Six.
Say. No. No, guess again.
3.
No.
3.25.
No, that's okay. Anyways, go.
Should it be an integer? Or?
It should be like integer.
8.
No.
7.
No.
Yes.
I didn't get it.
9.
Yes.
You always think of the same.
My head is there only. Okay, so exactly. If let's say I am the protocol and you are the miner, this is how literally proof of work works in the molecular level. If we are talking about, the protocol says guess a hash, and then the miner, all they do is guess that hash, and we're going to look. Yes, and I'm going to show you how that works. It's very simple. I'm telling you, I'm a techie, and I'm going to break that down for you. We just
Any prime numbers involved there?
Yes, but we get into that.
I'll get into that, and I'm going to show you, right? So now it looks so simple because I said guess a number between 0 and 10. Now the protocol doesn't do that. The difficulty is adjusted based on the miner. Let's say if we all form our own blockchain and we're trying to mine on our and our blockchain uses the proof of work algorithm, right? And we're all using Windows computers. So and then Alvin realizes he's making money out of it. So he just upgrades his hardware, and because Alvin has upgraded his hardware, the protocol will have to now adjust the difficulty so that Alvin is able to mine the block between 8 to 12 minutes. Because if the protocol keeps the difficulty based on our machines, right, our configuration, Alvin will be able to super easily mine blocks. So there's a very big example of this when China banned crypto mining, right, or Bitcoin mining. And everybody in China had to shut their data centers down. That's when a lot of difficulty power was removed from, like, a lot of power, miners on the blockchain had to be removed. So that's when the protocol immediately had to, like, the difficulty fell down by significantly at that time. So that's what we are looking at. The protocol literally tells you to guess a number between 0 and 2 power 256. We're going to talk about why 2 power 256, but this is, and literally the example that I told you, right? This is how mining machines look like in 2011. It's just some hardware. And this is how they look in 2025 now. They're big data centers.
When did this happen in China, roughly? What year was this?
2000, they banned it twice. I was there in 2013, 14, once they banned it.
That was the first time?
Yeah.
China has banned Bitcoin multiple times.
Yeah.
And that's come on the Bitcoin magazine in the front.
Yeah. But so the first time was 2013.
Yes.
I think so. I
Before
was
the
there.
launch of Ethereum, still, right?
Yes.
Otherwise, all the bitcoins would have been in China.
2016.
Yeah.
14 pre-sale,
Yeah.
16 launch, January.
Yeah.
Long gap. And that blockchain 2.0, I would say Ethereum was 2.0.
Yeah, Ethereum was the reason, and we'll get
I
into
would
that.
classify that as 2.0.
So these are some just numbers on how much energy is required. It's literally the same as a country like Argentina for Bitcoin mining, right?
Can you go back on that? I'm just curious because I know some guys who are putting up Bitcoin mining.
Here in Canada?
You need lots of scale now, right? Lots of scale and really cheap energy to compete.
They're looking
So
for
the
cheap
largest
energy.
mining in Canada is on Edmonton side. I know
Yeah,
that.
because of
Edmonton
like,
will have power there.
yeah.
No, the thing is, it makes only sense if you get
Very
power
cheap.
at. I know one guy. It makes only sense at 5 cents a kilowatt hour.
At this point, I agree. But Canada's that side mining, one thing I'll tell you about miners, they won't take you to their site. It's a dangerous risk. Usually people they don't show you their physical mining site.
Yeah.
Why?
Scammers pretend to have it and they come at you. B, if I show you my mining site, your neighbors are complaining, electricity board is complaining.
Yeah.
I quietly need to make money unless I'm also now powering.
Yeah,
my
nobody
site.
announces
People
that
don't
I
show you
am
their
a
mining
miner unless they wanna like fake it and
This
show
is what we
off.
were talking about yesterday, right?
Yeah.
Less is
Yeah,
more. Less is more
I
in
know so
crypto
many
world.
people that mine but do not tell anybody that they mine.
Yeah.
I used to mine. I used to mine back in the day with CPUs like that. I mined Dogecoin, I mined Ethereum. But what I'm saying is those days you could do it with GPUs.
Yeah.
We mine here.
Now you
with
can't do
ASIC.
Bitcoin
One
now
of our
anyways.
ASICs is here. See that one in the corner there?
Yeah.
That's the one we did Bitcoin cash.
See, that's what you would have been a billionaire by now if you continue.
Array,
It doesn't work that way. That's what people think it is easy money,
I know,
but
I'm just
it's
kidding.
not easy money.
You need to upgrade the hardware, right?
Not just the hardware, it's also the regulation that comes into the picture when you say that you are making money by burning electricity at the same rate that you are like general public is paying,
And
right?
you-
But you're not only it's not burning electricity, but you're investing in GPU.
No, it's not just electricity, but I think also dependent on how much energy and the natural
I'll give you the final conclusion.
carbon footprint that you are increasing of
Bitcoin
the.
mining, Bitcoin
Uh-huh.
is not for the faint of heart. If you're sitting here today, you're taking it on your chest. Otherwise, it's not going to be easy. Take it from me, whatever you're doing here
Mhm.
is not easy. Whether it is the mining where you blow up the electricity, your wife has to scream, that was how I began. Or now where you're getting all these regulation issues, whereas they can waste electricity somewhere else. Bitcoin itself, the way it goes up and down, the negativity that you face, the struggles you have to take on, nothing is easy. So just the rewards when they come, because of the hard work, they are really worth it. Worth it. So please take it on. I'm not kidding.
Anyways, getting back to our presentation, this is the data that you wanted to see, right? Where 0.55% of the global energy goes into Bitcoin mining of the world. I'm talking about.
How many have been mined till now? 18 million?
19.
Yeah, 19, I think.
There's not much
around.
left.
But I think it would take. Yesterday, Alvin was mentioning it would take 2140 to mine all of the Bitcoin,
Yeah.
right? Yeah, 2140, not even 2040.
21 is such a small amount that's left, right? It's because the curve, it diminishes, right?
Yeah, the block reward is like.
Yeah, it gets very, very small. So it's
Yeah.
like 20, by the time you pass, we pass like 2050, 2030, 2050, it's less, it's not that it steepens out to be very, very, very
So
big.
here's how
It's less
that's
than-
happening, right? The amount of 1 BTC is increasing. That's why. So that's how that is the reason that it's still on 19 million or 18 point something. Yeah, the 1 BTC was we just saw yesterday. 1 BTC was 0.1 cent when it started, and now it's at 100k,
No,
right? Or
not
somewhere
that
around
high.
80k.
No.
Then what?
The calculation is like there won't be more than 21 million bitcoins. So like first it started as 50 bitcoins as block reward, then every
No, as not as block reward. They're saying there wouldn't be left to mine.
Yeah, there would like 2140 there would
After 2040, yeah.
Yeah.
2140. That's like
15 years.
150, 200 years.
115 years.
115 years. So I am pretty sure none of us will exist till then, at least given the rate at which we're living. So,
Sure.
So that's not our concern at the minute. We're looking at how balances are calculated on Bitcoin, right? And there was the UTXO database that we talked about. Now, what is a UTXO? It's unspent transaction output. Okay, it literally stands for unspent transaction output. Now, what we want to categorize is Bitcoin is all the money on Bitcoin is nothing but a UT. But stored in the form of UTXOs. So let's say Alvin and Sat want to do a transaction, right? And Alvin has 10 BTC, Sat has 5 BTC, Alvin wants to send 2 BTC to Sat. So Alvin's UTXO, if let's say Alvin has one UTXO, it gets divided into two, where one is 8, the other is 2, and then that 2 UTXO gets just ownership is transferred of that 2 UTXO to directly to Sat. That's how it works. Basically, that's what we should. So a person can own multiple UTXO transactions, and the total of that UTXO would be his balance, his current balance. That's what we talked about. Now, how does transactions work? You need your private key and your public key to send out transactions. Now, this key, the signature, the digital signature that we are talking about, uses elliptic curve cryptographic algorithms, where it's a ECDSA signature. So if you, let's say you have two keys, the private key and the public key. Now this is common knowledge never to share your private key. The reason being is your private key can actually derive your public key. Your private key is your identity, right? But there's something your public key cannot, the reversal is impossible currently, which can be broken by quantum computers later on.
Really?
It's assumed that way, but we don't really know, because cryptographers that are working on these I mean it. What?
Computational power is not there, like.
Exactly, and in my personal opinion, inserting my personal opinion here, but a lot of cryptographic scientists and researchers say that by the time the computational power for quantum computers gets generated, by that time cryptographic algorithms will also have advanced to the level that they are quantum resistant or quantum secure, right? And we're going to be talking about those as well. But here's the thing that we discussed yesterday, that your private key plus a plain text message becomes your signed message. That along with your public key will show that you are the one that signed this message. So the major question that we tackled was, will you get can you be hacked, right? The only way you can be hacked is if you are somebody who just gave out your private key. Because if a hacker uses their own private key to assign the message, and along with your public key, right, the algorithm would, or the protocol would know that this is not signed by you and it's a fake transaction. But if a hacker gets access to your private key, then he got access to your identity, and then that's on you. Why is Bitcoin a blockchain? Is because this is where we discuss how it is a blockchain, right? And what data is stored in each block. So there's the header and there's the body. For this particular one, let's start with the body, where all of the user transactions are there, and then a coin-based transaction is. Now, what is a coin-based transaction? It's the amount that is going to go to the miner. Right, so remember we had a reward rate which was 3.125, and then along with that, each transaction has a miner's cut in it, which is the transaction cost to execute that transaction, right? So all of those transaction fees plus the block reward makes the coin-based transaction. Now the thing here is, it's assumed, because the reward rate is cutting down, it's assumed that the transaction fee would become so much higher, that would motivate the people and to keep the network subsidy going, right? Apart from that, each block, like I said, holds the address of the previous block. Now when we were talking about the 0 to 2 power 256, guess a number between, right? The 2 power 256 comes from SHA-256 cryptographic algorithm. 2 power 256 is greater than the atoms in the universe. That's the one that's used by the protocol for mining, and for wallets, RIP EMD 160 is used, which again is 0 to the 0, anywhere between 0 and 2 power 160, which is again more than the atoms in the universe.
How do we know how many atoms are there?
So there's like, I think science has proven that there's this much number of atoms in the universe, so that's why there's an estimated number of
What is
atoms.
POW? Useful for?
Proof of work. So you can put anything through the hash function that will give you a hash output. We'll look at how that works. If you put hello world through SHA-256, that's the output that you get. Now, because this is an encryption algorithm, reversal is not possible. So how do you verify if this is the right hash? Means you should put the same input again, you'll get the same output, and then you compare those outputs. Even if you change a single character, like we added exclamation mark there, you will see that the entire hash, even there's no, like, the start of the hash is different and the end of the hash is the same kind of thing going on here. It completely changes. It's because it's encryption. So if you want to reverse a SHA-256 algorithm, it would take more than, like Nitin said, there's no computation power right now, because it would take longer than the age of the universe currently.
I don't know, maybe it has.
Let's not get into Area 56 conversation, please. But how does Bitcoin use SHA-256, right? So each transaction that you see is put twice through the SHA-256 algorithm. So firstly, the transaction put through the hash function would give you a SHA-256 it would give you a hash, and then that hash is put through SHA-256 again to achieve this hash. That again combined with both the hashes, then it becomes a hash, and we talked about this. The leaves are all the way combined until you have one root hash left, right? And this is what a Merkle tree is. This is the concept of a Merkle tree, where it's used to basically understand proof of inclusion, as well as to look up if your transaction was there in the if it was included in that particular block, right? So and if there's a fake transaction, or how do you determine if there's a fake transaction or a real transaction? Through root hash mismatch. Now, like I said, Merkle proofs are used for that. Again, revisiting proof of work now. What happens is, when you get that root hash, right? Now, once you put it through SHA-256 like hash function, you encrypt it using SHA-256, right? And you get a block hash. You tell the protocol that this is my hash, and if the protocol says no, right, then even if you put the block header multiple times through the same function, the same block header through the same encryption function, you are going to get the same output. So how do you basically how does this become different, or how do you change that output, or where that randomization guessing game happens, is where the concept of nonce is introduced. My personal opinion, it should stand for nonsense, but it stands for number used only once. Okay, so what they do is, this nonce is a number that is added to the block header, okay, and passed through the SHA-256 algorithm to get a block hash. Now, each time the protocol rejects the block hash is when the nonce keep changing. This is where the randomization process of guessing that number happens, right? You're guessing the nonce number. Now, for example, if you look here, the block header with the nonce 589 got approved, right, by the protocol. So once this number 589 is approved, then it will never be used again. Like, once the number is used and gets approved by the protocol, it's never used again. So that's how nonce works. So revisiting how the header looks like, the header has the Coinbase wallet, which is the miner's wallet ID, the root hash, the nonce, and the previous block hash. Now all the blocks have a previous block hash except the Genesis block, which is the first block on the blockchain, right? Now we move on to Ethereum, where we were talking about how Ethereum was founded. Vitalik Buterin, who's the founder, moved from born in Russia, moved to Canada, co-founded Bitcoin magazine, and he was a technical content writer when he understood the limitations of Bitcoin and understood that adding new functionalities to this blockchain required hard forks. So he proposed a new type of shared world computer, right, where it would be programmable, and it was only an idea until it became called Ethereum. Now, Ellie Van Sanson is the founder of Starkware. Remember I mentioned Starknet Foundation doing this Basecamp. Their for-profit organization that handles research and technological advancement is called Starkware, and Ellie Van Sanson is the founder of Starkware. So his major focus is on zero knowledge proofs, which I will again give an overview about. But he was invited by Vitalik for an interview at the Bitcoin magazine, and Vitalik invited him to invest into Ethereum, but he said he doesn't invest in things he doesn't fully understand. He regrets the decision till the date. But when Ellie launched Starkware to create ZK rollups, Vitalik was the first one who invested, and he is listed as an angel investor. That's pretty much that we discussed. Now we started talking about high level and low level programming languages. High level programming languages, any language. They are the examples: Solidity, Viper, Cairo, Rust, JavaScript, Python, right? Object oriented programming languages. Low level are assembly languages. Now here's the thing: Bitcoin is written in Bitcoin script, which is an assembly language. Just to give you basic gist of what a low level and high level program, everything on that the computer machine understands is in binary, zeros and ones, right? The layer above that is the assembly language layer. So any programming that's done in assembly language directly communicates with it just requires an interpreter to communicate with the machine. While the layer on top of all of this is the high level programming language. That's why it's called a high level, because it's on the top. It's on the layer above, where this language is converted into it uses a compiler to get compiled, and then the interpreter runs through the compiled output, and then it's converted into the machine code, right? So that's the major differences. Now Bitcoin is written in assembly language, while Ethereum is written in a high level programming language, Solidity. Here's the thing. This is a quick depiction of how the protocol / the blockchain looks like, right? All the programs are written on the protocol, and any changes would require you to do a hard fork. Now on Ethereum, if you see, the protocol level exists, the protocol layer exists, and everything is written on top of this layer without any hard fork of that sort, right? Now any operations that are run on Ethereum, or the concept of the world computer that Vitalik proposed, uses the concept of gas to measure transaction fees. It's directly proportional to the complexity as well as storage. Now a lot of people think that that's fine. A lot of people think that gas is basically a lot of people, including myself, think that gas is a fancy name for transaction fees, but
It's a subset, right?
I mean, yeah,
It's a
sort
subset.
of,
It's a
yes,
subset of
yes. I mean, people in tech really like to complicate things, so we call different names to the same thing. But the reason that gas was originally introduced is different. It was not just for transaction fee, but this is Alan Turing. He's a mathematician. He was the mathematician that solved Enigma, the German, basically what?
Yeah, the machine.
Yeah, the machine. At least somebody knows. Somebody does. No, the machine. Because when I said this yesterday, everybody was like, oh, no, we
Turing
don't
complete.
know.
I said
Yeah, Turing complete.
But
Like,
Vitalik-
he's known for breaking the enigma.
Yeah, if not for him, everybody would be thinking
Yeah,
that-
we will all, yeah, like we're live and I don't want to.
Make it like-
Okay, we are Aryans. We might as well have spoken German.
At that point, no, but then they figured out, and that's how they won the war, right?
Yeah, but like
Well, I don't
If
think-
you
I-
if
I
you're
mean, in the end,
referring to
Germans
the
would have lost
imitation
anyway.
game, if you're referring exactly to the movie, then it does show in the movie also that like in the start he doesn't.
yeah, like at first we
At first he doesn't, but he's the one. So if in case you are a mathematician, the highest form of recognition that you can get is a Turing award. So that guy also basically he found he introduced the halting problem where there are two types of languages. If a programming language is supporting loops, whether it's for loop, while loop, do while loop, loops are prone to something called as getting into a deadlock, right? Because of infinite loops. Now, a Turing complete programming language is a language that supports loops, and a non-Turing complete programming language does not support loop. Bitcoin script is a non-Turing complete language, and why we're learning about Turing complete and non-Turing complete is because infinite loops can be used by hackers for DDoS attacks. Distributed denial of service. What I mean by that is if you crowd the network or you congest the network, right? That's when there's a huge chance the entire blockchain might go down. So, but the issue with Solidity is it is a Turing complete language, so it supports loops, and the concept of gas was only introduced to basically mitigate this problem of a Turing complete language. So they did. So it did not definitely prevent infinite loops.
What do you mean Vitalik's? It wasn't Vitalik's idea, you know that?
What?
It was the legal team who gave them the idea. Yeah, saying you guys are not around.
Did you look at, I mentioned this yesterday, but if you look at Vitalik, you definitely will think he's just a guy that he's just a kid that
knows everything.
That
I was
does
gonna
not
say,
know everything.
I always thought he was gay, but now we are recording, so don't get into this. I'm just saying, listen, I know this, that it was the legal team. The idea of gas came out from the Ethereum legal team. I was there when it happened. I didn't understand gas, so when I heard it, I was
meaning like the calculate of gas.
the concept of
The
gas
concept
was not
of gas.
originally part of.
But
So
like-
the idea of Ethereum was existing.
see, the idea of Ethereum itself, right, was just an idea until it was called Ethereum, and then the foundation was found and everything happened.
So Satoshi did not implement the idea of Ethereum because he wanted to test out the coins idea. The
Yeah,
money
the cryptocurrency
The
idea.
idea existed at that time, but that generation didn't have the luxury of being able to implement it. Our generation, or whoever, Vitalik and all, came in. They all knew this was the next iteration. I didn't. I get that I missed out on Ethereum. But when it was being developed, gas concept came from the legal team. I remember this. I'll find the article just in case. Anyway, let's continue.
Anyways, so the beauty of gas, the concept of gas is that there is a limit defined for each transaction and each block. It definitely does not prevent infinite loops, but it does prevent DDoS attacks. Now, moving on to Merkle Patricia tries, which Gavin Wood, who's also technically the most technologically advanced person right now because he also wrote the first interface of Ethereum. Now, Merkle Patricia tries are basically derived from the concept of Merkle tree to use. So we looked at the concept of Merkle trees. Now, Merkle trees, the issue was they're good for lookups and they're good for proof of inclusion, but they're not good for storage. So so Gavin Wood invented this concept only to expand on the storage part, where he wanted it to, where he wanted Ethereum to handle the global state and do more with the whole concept, right? And this is how it looks. It's faster. It can store large amounts of data and pretty easy lookup, right? Now moving on to, this is how an Ethereum node looks like. There's the consensus layer and the execution layer. Consensus layer participates in proof of stake algorithm as well as tracks where the chain is currently headed, while the execution layer executes the transactions and manages the global state of the blockchain. What is proof of stake, right? It's super simple. Now, because proof of work required so much computation power and also is slow at times, what Ethereum introduced was a validator, which is equivalent to a miner on Bitcoin, right? A validator stakes their money, 32 ETH, into a deposit contract. This will unlock them the ability to validate blocks, create blocks, attest to the blocks. Now, how is this proof of stake algorithm tackling the cheating or the discrepancy part? Is that it basically has the concept of slashing, where what you have deposited or what you have staked on the blockchain gets slashed for two reasons majorly. One is if your node goes offline, which is the slashing amount is pretty less, but the other one is if you cheat, like if you attest to fake blocks or if you try and create illicit blocks, then a huge chunk of what you have staked goes away. Now, validators are humans and machines together. It's not just a machine. So, moving on to, yeah, we did see what Bitcoin and Ethereum is. And then I'm going to move on to a quick recap and then we can start with the Bitcoin integration. So, like I said, Starknet Foundation, that's for profit, non for profit, and we did this just now where we talked about Bitcoin and Ethereum. Now we're going to talk about scaling Ethereum. Ethereum's congestion is a very huge problem. This CryptoKitties is the first NFT that came into the picture. Initially, Ethereum was a very ideal system with a very ideal scenario because it wasn't popular enough, so it didn't have much demand. So low demand meant cheap gas fees and cheap transactions. But in 2017, when CryptoKitties was launched, it became so popular that it consumed 15% of Ethereum. And it actually triggered a bidding war for block space, which was $3 per transaction. Now, if you look at today's scenario, again, this is due to currency debasement that in our head we're like it's just $3, right? But the second wave of NFT collections in 2021 saw $100 per transaction. And Ethereum became so congested that it became unusable. I mean, Alvin yesterday mentioned that he almost paid like for a transaction. In transaction fees, which is like crazy, and that was not the whole idea of why this came into the picture, right? So Ethereum needed to scale. Now, if you are a cloud engineer, there are two ways of scaling a system, horizontal scaling and vertical scaling. What that means is basically in one of them you introduce a lot more machines which are inexpensive machines, which is highly decentralized, it's robust and it's secure. The other way is you increase the computation power of your current machines as well. So you scale upwards where you are, it's fewer nodes but more powerful ones. They are less decentralized and you are kind of compromising on the security, but it's one of the ways of scaling. Solana uses that way. Now moving on to how rollups and layer 2s work. This is very important. I'm going to go back to this topic because we had a very beautiful conversation yesterday just to explain what a rollup and the difference between, and I feel like we did not really.
I was dreaming about it.
The whole yesterday after going home I rewatched and I was like, no, this is not how I can end rollups and layer 2s, because I feel like we left it at a very let's let go of it kind of situation. So I'm just going to explain to you what a layer 2 and a rollup is, okay? And this I'm going to do only once and we're not going to look back at it again. So layer 2 is basically the Ethereum or any blockchain that we're looking at. That's a layer 1 is the foundational layer of is the foundational or fundamental protocol that we're looking at. Now layer 2 is everything that's built on top of like Ethereum or any other layer ones that we're looking at, right? Now, there are types of layer 2. What are the types of layer 2? One of the types is roll-ups. This is much better than saying that all roll-ups are layer 2s and layer 2s are not roll-ups, okay? The other is state channels. And then there are others, like depending on the use cases, right? Everything that's built on top of a layer 1 is a layer 2. Now this layer 2 can be of different types. We talked about the lightning network yesterday. It's exactly, it's a state channel. Yes, so it's a state channel. Now for scaling, when we are using the roll-up part that we're looking at, right? The major difference between a roll-up and I want to portray this out to you. Where is that? There was this beautiful table that I saw on Medium. Just a second. So wait, I'm not able to find that anymore. But like I said, the roll-up part, right? This is when you have to finalize all of the transactions on the L1. Now, yes, state channels and side chains might have to do that, but that depends on use case to use case. A roll-up is only when everything on the layer 2 has to be verified on layer 1 that it happened. That's why it is called a roll-up, okay? The concept of roll-ups was came into existence because of Ethereum. That's why when you're rolling back to Ethereum as a layer 1, that's when it's called a roll-up. Understood? Are we in the clear? Perfect. Now there are two types of roll-ups: optimistic roll-ups and ZK roll-ups that we looked at. Arbitrum and Optimism are optimistic rollups. ZK Sync and Starknet are ZK rollups. Okay, and we're gonna look at what the difference is now. Now, since this is the protocol layer, right? Now these rollups, another major reason is they depend on the layer 1 for security. Like they depend on layer 1 for security. They are a solution only for scaling. That's where we're introducing rollups, right? They're used as scaling because that sequencer executes all of the transactions and the finality happens on layer 1. So, but all of the security is still coming from the layer 1 protocol. Okay. So now coming back to optimistic and ZK rollups. What's the major differences? There are 4 types of why is this not now? Yeah, there are two. Before we move on to optimistics and ZK rollups, there are 2 things when we're looking at L1 finality, right? On rollups, there's the block space and there's the blob space. Now, the concept of blob space was only introduced last year in March. And it was created specifically for rollups, but anybody can use it. Why? Because rollups have to validate all of their transactions on back on layer 1, right? So instead of using block space, which is a permanent storage on the EVM, they introduced a temporary storage that's only for 30 days. Now third party people can act and store this data long term, but blob space is initially meant to only be stored for 30 days. All of the large transaction details are what's stored in the blob space, and then they get verified. And this is the difference between optimistic and ZK rollups. Now, in optimistic, when rollups eventually came into the picture, the main rollup to come into the picture was optimistic rollups. ZK rollups were still a myth. Or not just I wouldn't call it a myth, but they were just a how do you say, theoretical concept. Yes. So optimistic rollups believed that the sequencer that we are talking about was honest until it was proven otherwise. right? And their security measure was, let's say, unless and until somebody pointed out that this is a fake, it's a fake transaction, a fake, something is malicious in this activity, that's when a fraud proof was only generated, which is the reason that the L1 to achieve L1 finality using optimistic rollups, it takes you over a week, because the validator has to go through the entire process of verifying all of the transactions, right from looking at the at those large transaction details, all the way to verifying state roots, L1 and 2 messages, all the commitments and everything, right? So the block space stores fraud proofs, while here in ZK rollups, what happens is every time the sequencer's honesty is verified using it's verified on a regular basis, and it's verified using something called as validity proofs. Because every time you give this verification or validity proof to this to L1, it only takes a few hours to achieve L1 finality. Now, block space here does not store transaction details, it only stores the state differences between the two transactions, right? Moving on to the evolution of ZK. Now, Charles Hoskinson, we also discussed how Charles Hoskinson, the founder of Cardano, basically commented on the concept of ZK rollup, which Starknet was building, and he did mention that it's going to require years and years and at least 5 to 10 years to practically implement a ZK rollup that Starknet was proposing, but Starknet did it in just under a year. So that's there. Now we talked about
When did he make that statement, and when did
in 2020,
20?
and we launched in 2021. Yeah. Now we talked about validity proofs and how the sequencer is presenting a verifiable computation, right? What does that mean? And that's where the space exploration problem came into the picture, where let's say you're a scientist, you want to go to Mars, and you are writing a program in Rust but do not have enough computation to execute it. So you use the supercomputer of a rival country to execute the program and get a result. Now with the result, the only problem is that there's two issues. You do not know whether it is the right result, because there are two ways that it can malfunction. One is the supercomputer itself malfunctioning, and then there is also an issue of sabotaging, and that's the reason we took a rival country in this example. But what happens when you write the same program with Cairo and execute it on a supercomputer, right? You get a result and a proof along with it. So whatever is generated on the supercomputer comes out with a proof that can be validated on a regular computer. So computation power is basically regular computers are able to keep a supercomputer honest. That's what we were discussing. Now the beauty of Cairo is it enables verifiable computation, runs on top of Cairo OEM, syntax is inspired by Rust and similar ownership models. You do not need to know ZK to use Cairo, and it can be used outside of Starknet. It's an independent programming language on its own. We have to get back to that live demo because I didn't show that yesterday also. Validity proofs. Now, what are we actually looking at here? The L1 scaling problem was that validators, when a block was produced, right, they had to validate the entire block. They had to run the computation again on their system, right? But with Cairo's validity proof feature, let's say somebody generates a new block and they also present a proof. The validator has to only run proof on the system, and the difference in the computation power, if you are good at math, would be x versus x to the power of x versus log x. So let's say if x is 10, if it's taking 10 seconds for a validator to validate the whole block, it would only take a second for the validator to validate the validity proof. So that's the major difference. Now, just to give you a better example, validity proof to a computation is same as a zip to a file size. again, validity proofs are a use case of zero knowledge proofs. Now for zero knowledge, yesterday we did a very good example, which was can somebody tell me what that example was?
Is it a tunnel?
Yeah.
You went to Nitin
Yes.
and I got lost.
No.
Literally.
No.
Uh,
Okay. So we'll take Nitin again, and we'll take no,
Yes.
and then we'll take Sat. Okay. So Sat says to Nitin that there's okay, yeah. Sat says to Nitin that he has the so there's a tunnel, okay, and this example is inspired by the Alibaba and the 40 Thieves story. So let's say there's a tunnel and then there's a hidden door, hidden treasury door or whatever, and Sat says to Nitin that he has the key to this door, but the moment you show the key to Nitin, Nitin is able to duplicate it. So instead of showing the key or showing the information that Sat has to open this door, what does Sat do? Sat just goes from here, opens the door, exits from here, so that Nitin knows that Sat has the code to the the door, right? So this is a prime example of zero knowledge, because it shows that without giving out any essential sensitive information, you are able to prove something, right? So it is a huge the biggest implementation of a zero knowledge proof can be in digital identity, where we're not giving out any information and still being able to prove that we are a legal citizen, along with if we are eligible for whatever we're looking at. Like yesterday we were discussing the example of being over 18 to, let's say, purchase alcohol. So if you're how do you verify that? Do you have to show your age, show your date of birth, or your physical ID, right? And instead of doing that, you're just you would be able to have this. I think we talked about Sing passes from Singapore. Yes. So those where they are implementing digital identity using CK, right?
allegedly.
Actually, they can use
Alleged.
this.
To be
Huh?
They
confirmed.
can give a digital.
That's what I've heard. I haven't.
Everybody.
What?
That can use to. They can give a digital ID to every citizen,
Yep.
and that person has to enter that if he has to prove that he's over 18 or.
Yeah. That's a very.
Huh?
Eventually, I think that's what's gonna happen.
I think that's the way it should
All
go.
these
What do you think of that idea?
What?
Everybody gets a DI and.
That's the.
Like when you tap with your card, like you get I think it's in
Everybody gets a digital
Tap it with your
identity, and that
machine.
one thereby.
You can, when you're going to enter a site,
Yeah.
you have to enter your ID. But the problem is, depends what kind of site. Some sites you don't want to give you want to remain anonymous, even if you're over 18.
It's not just about anonymity, right? It's about you're giving. I mean, even if you want to get into a bar or a club, what do you have to do? You give your digital ID. Nowadays,
But the
some
thing is,
people
but the
have.
problem is you don't want to keep it.
Some people-
You don't want a footprint of people knowing where you've been. Now everybody can keep track. The anonymity is
Can
gone.
you?
If you give your digital identity.
Hey, you know what? This is something we can actually work on. This is a,
No, my question is, can you? Would you know how many times I went to a bar just by looking at a physical ID?
no, not that. But if you have a digital ID, now you know. There's already a track.
Oh, you mean the guy?
Yeah, China.
No, if you have a digital identity with a ZK proof, then nobody can track you.
Because you're not giving.
Because you're not
anything
giving
else
any
Other
information.
than the fact that you're a
I'm
yeah, other
talking
than
about
the fact.
digital ID.
Yeah, which is only you, right?
Yeah.
And if you
No,
can-
even on the system, I'm talking about the system as well.
Yeah,
Like
you know what? There's always somebody is keeping track. There's no way. Everybody says there's no
No,
track.
No. That's the whole idea of
Oh,
ZK
zero
proof,
knowledge.
right?
Whole
Now,
idea
when
of
if let's say I am the developer of this digital identity system
Okay.
that we're talking about, and
Whole
I
idea
want
comes
to keep a
in
track
today.
of you guys.
It was not possible before as easily as ZK. can
Yes,
do it now.
So
and
that means you can use it for anything.
you can use it for anything, and you will not have a
Okay,
digital
this is only
footprint.
The only case you can use it is over 18, but there must be more cases.
There are many.
There's so many cases.
Yeah.
Medical history, I don't know, concealing your, like you said, if you didn't want a footprint.
Network. They just want you to have 100K. You don't have to reveal you have that much more. If you just
If let's say
reveal
entry to some entry to those private conversations that you're talking about requires you to have a net worth of like 100K, then you don't have to just show how much
You
net
need
worth
to
you
show
have.
that.
Generally, if
Just
you show
tap.
a document, the document shows all the money you have. Even government requirements for immigration and other things. No, they want you to be above a certain.
No, even when you're requested, they ask, you show your net wealth.
Yeah.
Are you an accredited investor?
So even accredited investors have a certain valuation.
They need to
What
have
if I have
valuation.
100 million more? Why should I tell them? This is the problem. This is something.
The
that's
major
solved.
thing that we're trying to solve, right? Exactly. So that's the validity proof is just a use case of ZK, and it convinces basically the verifier on L1 that the new L2 state that they're talking about, without sharing any transaction details, is real and the truth. Now, it does not make L2, one thing to note, it does not make L2 transactions private, but it's just not giving out that information to L1. It does make verification more efficient, as well as it's now the validity proofs that we're talking about, it's based on Starks and not Snarks, and we're going to look into what Starks and Snarks are. It's efficient for proving and verification. Now, yesterday, something that we missed was the last time that I was conducting this Basecamp, right, one of the students had this question that generating a validity proofs or generating validity proofs in computational sense requires is more expensive than an optimistic, like a fraud proof, right? Because fraud proofs are only generated when somebody points out a malicious activity. Otherwise, you don't need fraud proofs. It just takes a week to reach L1 finality, right? So that's the thing. They may be more computationally expensive, but they are efficient in terms of like in terms of execution. That's it. So that's something that I
And
wanted.
more efficient in terms of validation.
What?
Yeah.
In validation, it requires less time also, and like there's one thing that you need to let go to achieve the other sometimes. So Stark versus Snarks. So Starks and Snarks are both basically validity proofs only. The only differences is this takes the verification time for a Stark is log of n, while Snark is it's a constant. Now the proof size is 400 KB here, it's 288 bytes here. Proving time is only just 1x, here it's 10x. Now what we talked about a trusted setup was, do you need a trusted setup to set up a Stark validity? No, absolutely not. While for Snarks you do need, and Starks are quantum secure while Snarks are not. So that's and why did Starknet choose to upgrade to Cairo VM instead of any ZK EVM is because of performance and not just compatibility. So the problem is the compatibility with EVM decreases because you change the whole programming setup, right? That is why, but because of the performance that they were looking at with Cairo programming language, they upgraded it to Cairo VM. So right now Starknet, a ZK EVM rollup, uses Cairo VM to validate its transactions as well as like perform transactions generally.
So was Cairo originally invented for Ethereum?
No.
It was invented for Stark. Where did Cairo originate? I'm just asking because I heard that Cairo.
Yeah, but I am not Wikipedia, so we can Google.
No, don't ask. Don't
Wait,
ask.
we
I
can
know the
Google.
answer. Because I've heard Cairo before, and I know that Cairo is one of Ethereum's forks. But then now you're saying Cairo inside Stark, so I'm like, was that VM just?
No, the validity proof Starks was developed by them, but
Cairo VM, Vicky.
no, it's just a virtual machine that's using Cairo.
Okay.
But Cairo programming language was
Rust.
it's Rust
Starkware.
inspired by Starkware only to create programmable proofs.
Okay, I guess you would need something unique to create nodes. And if that's the one.
What do you mean unique?
Have you known the difference between COBOL and Fox Pro? I'm just saying. So you need something that works for what you're built. And that's why they
They had to
build
like
They
it.
have to
So
build
the
it.
entire syntax is like Rust only, but it's just a bit upgraded, right? Now the L1 finality that we looked at on optimistic rollups is 1 week. On Ethereum, obviously because it's layer 1, it's 6 minutes, but because of congestion, not usable only. Starknet, it's 5 hours, and pre-conf is less than half a second. So, and a Starknet has the power of doing 1000 transactions per second on the mainnet, and they are cheap. And yeah, that's pretty much it. I think that's what we did yesterday. Oh, we did talk about smart wallets as well, where we talked about what's the difference between a regular wallet and a smart wallet. Is smart wallet basically decouples basically allows you to sign transactions with Touch ID or Face ID, and it allows you to execute multiple transactions in a single transaction. Now on Starknet, every wallet is a smart wallet. There's no externally owned accounts, and it uses account abstraction. What we mean by complex interactions or complex transactions is which requires multiple steps to be completed. So you do not need to execute each step individually. You'll be able to execute it in a bundle where you execute multiple steps instead of executing multiple transactions, right? Now, what's account abstraction? The decoupling of signer and the account. Now, the signer is basically a device that signs transactions. And the account is the smart contract on Starknet. If for a better practical view in a diagram, this is how it looks. The signer is your hardware device, the wallet, which would be, let's say, your phone, and that invokes the account contract, which basically runs the transaction and generates this target contract. Signature verification can happen through multiple ways on a smart wallet, which is single signer, multi-signer, hardware signers, session keys, as well as social recovery. They are supported by a couple of ellipticers, which we talked about, ECDSAs, right? There's 3 of them: Stark Friendly, SECP256K1 and SECP256R1. Depending on the secure enclave that you have. So if, let's say, we're converting all of your smartphones, in fact, has this hardware design where there's a shared system and then there's a secure enclave, and that secure enclave is the one that's being used to sign these wallets, to sign these transactions and create these smart wallets, right? Now, depending on the smartphone that you have, there's that's what that part of your hardware is called. For Apple, it's called the Secure Enclave. For Google, it's called Titanium, and then so on and so forth. That's pretty much it. We created a wallet on Bravos with 2-factor authentication or not. That's fine, and will obviously generate Spox later. Coming to Bitcoin integration. This is what we were talking about yesterday, and this is where we stopped yesterday. So what we are dealing with here is, now when we want to settle on Bitcoin, right? Starknet is the first ZK rollup to basically settle directly on Ethereum or Bitcoin, right? Now for Ethereum, they're already doing validity proofs and build this trustless bridge that uses proof of stake, right? But for Bitcoin as well, so that it's not just some wrapped token that you are presuming to be your Bitcoin. They want to directly verify and settle your digital assets directly on chain. So how do they establish that connection for Bitcoin? That's what we're talking about, Bitcoin integration here. Now the biggest benefit would be a trustless bit between BTC and Starknet, which would let us do cheaper and faster transactions on BTC. It's also highly likely that in the coming years, Starknet might replace the Lightning Network as a state channel. Yes. yes, that's what they're thinking. Because it's an alternative
It's an
to.
apples and oranges thing. In that sense, let's say when you're doing Starknet, you're doing it purely for zero knowledge. Right?
The main
Well,
USP, in my personal opinion, the main USP is ZK. But in my yes.
Lightning is just transactions. Yeah?
That's
It's
what
another
a
way-
roll-up can become. A roll-up can do state channel things. That's what they're saying. That this will become an alternative to Lightning Network because it's faster, cheaper, and more
And
efficient.
It does what Lightning does.
Exactly. It also does
So
what Lightning
that
does.
is where the question I was going to ask before you started is, what are the competitions to this that have reached this far? If none have, and it does everything that
Okay.
is required,
Mhm.
then it's like Ethereum. It's a first mover.
It definitely
In
is a
that
first
sense, and a
mover
first
in terms of
mover-
ZK knowledge,
a
right?
first mover
Zero knowledge.
always makes money. So
Yeah.
Ethereum was not the first mover, but it was the first mover with solidity. which was
Yeah, smart
Java.
contracts.
No, smart contracts existed on others, on Bitcoin, but it was not in
High level,
solidity,
yeah.
and it was not like JavaScript. You had 15 million programmers who just hit me.
Yeah.
I was like, what?
Because you could write solid
And
solidity.
you know what I'm saying? And that's what Ethereum took over some of these. I know there was Omni-layer and all. I was there before Ethereum, right? So I knew about all this. I just didn't know how to code. But the number of coders who came in at us and were like proud coders.
If you are no, if you take so as a developer myself, to transition into any language, right? If you are fundamentally a developer / coder, to transition into a language, it takes you less than 3 to 4 days.
Yeah, but JavaScript was the
Yep,
most. Yeah,
just understand syntaxes and
Yeah.
good to go. Because all the programming languages run on the same fundamental
Okay,
concepts.
and if you now this is for the 4 of us are now white coding, it's over, right? He's gonna learn white coding in the afternoon because I've been kicking him. Imagine he doesn't know it and he's not yet done it in 7 minutes. Look where a gentleman who has the capacity is now going to pivot into. We'll all watch
Yeah,
him. Let's
yeah.
all clap when he does it because he's not listening to me.
No, absolutely. Like I said, but that's the reason the high adoption on Ethereum happened because for a coder prior to ChatGPT / AI era, right? It only took us like 3 to 4 days, just sitting, putting your head down, reading the documentation. That's all you need. Coding was nothing but reading. If as long as you were able to read the documentation and understand what they were talking about, that's it.
It's the same principle now, just that your agent.
Now your agent will read and the
On your behalf, and
yeah.
then
So I
But
was.
the problem with vibe coding, my personal opinion, and sorry to interrupt you, is that a lot of people don't read what the error is, what the agent is saying, and what's happening. That's why they just go in those loops and loops and loops
I'll
of.
tell you the pros and the cons. See, I always start with this African saying is when an old man dies, a library fails. If you don't know what to prompt, because you don't understand the topic,
Exactly.
then you're not going to successfully write code.
Yeah.
I can only do ZK now because she taught me ZK and I have this.
No,
I
you
will white
understand
code
ZK
something.
now, that's
I
why.
get it.
Yeah.
I'll white code some solution for you by the end of the week after you get me hand holding through what you're doing
Yes,
today.
yes.
But the fact of the matter was, till yesterday,
You wouldn't.
I wasn't knowing ZK. I told you, we were old school. Me and you came in prior. So now,
So what was the expression you said to link that? You said that when an old man
when
dies,
an old man dies, the
fails.
library fails. He looks old, but he's got all the knowledge. So when you have the knowledge, like he's accounting, I'm guessing. He's a CA, right? You're a CA. You said that. He can do more than I can doing receipts manager, which I did.
Yeah,
Because
family
he's
finance.
knowledge. Yeah, he's
Yeah.
a finance guy. He can, the moment he writes code, he's gonna go from 0 to 100 in his. I'm not calling you an old man. I'm saying the knowledge. I'm trying to fight you guys now. This isn't about age.
Yeah,
This is
yeah,
about. So white coding's pros are for. So every
People that already know what they're
so
getting
every
themselves into. Yeah.
30,000 that have lost a job, 3,000 who are hired are the ones who know their stuff.
Yeah.
That's the advantage of white coding.
Yeah.
And if any idiot thinks he can write it in English, he's going on and on. Till I knew ordinals.
Yeah.
By 15 days I wrote the ordinals market. But
Yeah.
I was going at Antwa like, you didn't teach me, you taught Atika first.
Exactly. No, but because you learned it, that's where you were able to write it, right? Like just last month I was doing this interview segment with Blockchain North, where where the interviewer was asking, AI is going to take the jobs of developers. I like, please take. Blockchain North, Florent
There's a
Devenet.
guy who's in blockchain now. I think there's a
Florent.
common chap, but I can't remember.
Huh?
Florent,
Yeah, the guy from Montreal, French guy.
Okay, I know that guy. I think I've seen that.
Yeah, so they were doing a interview segment last month, and I was one of the interviewees, and they asked me developer jobs are going to go out in the next 3 to 5. I was like, please take. Like every vibe coder that I have worked with, I'll be like, please don't do anything. I will do your work and mine, because I do not have the
So around
patience.
5 to 10,000 will be rehired. Because even a white coder, he doesn't
Yeah.
have the time to bloody fix this here.
Yeah.
There's the time to white code after a month or two. Are you seriously telling me I should be running after a few $1 million or sit here and white code? The number of hours it takes even to prompt yourself through to a solution. I don't have 15 days. Okay, I'm saying, I'm not fighting you guys down. I've seen it, I've pivoted, and I understand what it means, but you would still want a team of 1 or 2.
Yeah, like I said, a person using AI can take your job, but AI alone cannot take your job. If it could, I would just hand it over right now.
This is not realized by the planet yet.
Yeah,
Yes,
yeah. A lot of people still think
They think it's all over.
Yeah.
They think it's all over.
They think it's all over, but if you are in the real world scenario too, it's far from over.
Well, I don't know. There's some jobs which should be taken over back.
I mean, yes, if you're talking about the overall scenario of jobs, yes, where manual work is required or monotonous work is required, where you're not technically using your brain, right? So in those
I know
cases,
one. I told you about this AI bot which was.
what happened to the no sugar? Yes, I'm telling you, guys are selectively.
Yeah, black coffee. And
Selectively.
I had sugar, but black coffee is just a better habit.
Anyway, not to worry. Yeah, you know what? I won't hold you down. I'll show him.
Absolutely.
Let's continue.
No, yeah, like I said, yes. So this is where Starknet is headed towards, where it wants to enable BTC or DeFi on BTC. And one more thing with this that would happen if we're able to establish this trustless bridge between.
Just one more question on this.
Okay.
Start
Okay.
off. You're saying, is the ultimate goal now of Starknet to be able to do zero-knowledge proofs
Okay.
and be a scalable layer 2
Yes.
for Bitcoin and Ethereum?
It's already for
You're already
Ethereum.
saying- but you're
It's
saying-
already for Ethereum. We're now working towards Bitcoin.
So, okay, got it. And you're saying it has the capability and to be as effective or more effective.
Why would you pick up, tell me, when you're using a Mac over any other system, is because the internal, the software, the hardware, everything is assembled together to work together more efficiently, right? Let's say you can assemble using different parts, but what if those parts were specifically designed to work with each other? The smooth transition that we're talking about, right? That comes from this integration that we're talking about. So now the problem is DeFi on. No, nothing. You did not do anything. I just need a charger. But DeFi on. Can you connect this one?
Yeah, we will.
Yep,
I
perfect.
think we will start.
Just a second. This one.
So SAT, right? SAT.
SAT.
So Lightning became so popular that I once walked into a Bitcoin maximalist meeting and a guy was only started off on Lightning. He didn't know about Bitcoin wallets. They used only Lightning wallets, not knowing that Bitcoin exists. So it had become popular years back. I never moved on to Lightning for my basic Bitcoin work, but Lightning has taken off for a lot of people with only those Lightning.
And it's just a state channel.
What
Current.
does that mean?
It's a layer 2.
Okay.
And it does what Bitcoin does, but much faster.
Why do you call it a state channel?
The state channel is only that. Let's say I'm a coffee shop. Okay, we'll go to Tim Hortons because we've been like promoting them, not like nonchalant, but unfortunately, yes. So let's say I'm Tim Hortons and I want to enable payments in crypto, right? But if I and the most popular cryptocurrency, Bitcoin, obviously. So, but for me to be able to receive BTC from you on layer 1 BTC is going to be
Minimum.
it's going to be 40 minutes. Oh yeah, or more.
That's right.
As a business, I do not have that much time.
Nor does the
Right.
customer.
Nor does the customer. He's not going to wait there and let's say, yeah, the coffee will firstly go cold. Next thing, what if the transaction doesn't go through? Then I am at a loss, right? Right. So what's a state channel is you create a layer 2 just so that you can have these transactions done much faster together and then verified on the L1. The L1 verifiability.
That's the term for the
Yes.
Okay, I thought it was
Yes.
Is this
It's a
called
state channel
Lightning?
only. What you are thinking, right? A different channel to between two specific parties to verify transactions.
Bridges the
Right.
state, yeah.
And then you bridge it back to L1.
Yeah.
Right. So the least that our trustless bridge can do is replace Lightning Network. But what it essentially wants to do is enable decentralized finance on Bitcoin. Currently, all DeFi solutions that you see use Ethereum or other solutions. On Bitcoin, doing this high level smart contract development is not currently possible.
Rootstock was Solidity on Bitcoin and it never took off. I'm just
Exactly, and the reason that we have not been able to achieve yet, we are also going to see that. That's the end goal here with Bitcoin, right? The integration with Bitcoin. Now, how can we make this happen? There are 3 ways. My favorite one is which is the least possible, is the opcat. So opcat is I think you guys know what opcat is. Jerry used to talk about opcats. Yeah.
I was going to say Jerry, but I...
Exactly. It's an operand for concatenation that was that already existed on BTC protocol but was disabled in 2012.
No, it was disabled since the starting.
No, it was disabled later.
That's okay, guys. I still don't understand
Satoshi
that.
disabled that.
Don't worry about it.
Satoshi disabled it. Okay, wait. Let's just Google, right? When did opcat get disabled?
Quick question. What's the password? Bitcoin space base?
He will tell you.
Space guest space 321.
Okay.
D and D are
Disabled.
Exactly as shown. Bitcoin
Space
is
everywhere.
Space, yes, space.
Okay, in 2010 by Satoshi, yes. I thought it was by Gavin Wood, but I don't know. But they only disabled it due to security concerns because it could be used to create a denial of service attack. Now, since the time it was disabled, I think since the last BTC conference, or I don't remember, way before that, they have been talking about Bitcoin improvement proposals where they want to implement or get opcat back into the picture in a more efficient way, right? So,
They're still talking about it.
they've been talking about it for a long. Exactly, that's why I said this is my favorite
So
solution.
he foresaw this in 2010.
No, not
like smart contracts or like.
What?
They're like-
Do you think Bitcoin was created by a supercomputer?
I think it was Al Finney. I'm convinced it was Al Finney. Anyway, I'll get into that later. I've thought about it for many years.
That's the prevailing school of thought for many, many people.
Who would wake up 3 years later to protect his neighbor. God.
Most people think it's healthy, but they've also.
And half the documentaries on Netflix are trying to deduce Satoshi Nakamoto, so we are not here to do that, people. Let's get back to our presentation. So, like I said, my favorite way is the OpCat one because it's super simple. The moment the Bitcoin improvement proposal is approved and OpCat gets into the picture, it becomes very easy for Starknet to generate a start proof that is sent to Bitcoin and verified on chain with the Bitcoin script, right? It's on-chain verification. It uses native script logic, so you do not really require any additional scripting or how do I say this? Any additional programming required here because it uses the native script logic. You don't have to implement additional ways. But the problem is they have been talking about this for the longest of time and have not implemented the Bitcoin improvement protocol. They do not look like they are going to implement it anytime soon, so we found other ways. The first one is BitVM, where we are actually generating a start proof that is assumed valid unless it is challenged by a third party during a 1 week. So we are going the optimistic roll-up way, where we are producing the start proof, yes, but also we're assuming that it is valid because currently we cannot prove the validity on chain, right? So we are assuming it is valid unless it is challenged by somebody during a 1 week dispute period. Now this definitely does not require soft fork. The problem with OpCat was we wanted the Bitcoin protocol that's currently there to require a soft fork and an upgrade, but this one doesn't. It's actually very close to launch, but the problem is it's super expensive and there's a long 1 week dispute period. Let's say on the 7th day somebody decides to dispute the start proof, then go into this whole loop again. So that's closer to launch, but it's not a very efficient solution that we are coming up with. Now the third one, which is the Collider VM, where a start proof is sent to the Bitcoin protocol and verified on-chain with a custom virtual machine using Taproot scripts. Now Taproot scripts are basically, they require a lot of complex off-chain computation to convert a Stark proof from Cairo into BitScript, right?
Can I just confirm something?
Yes.
When you're saying a script, right? A script is basically now sending a sub-program out
Yeah.
and running that,
Okay.
and that's how it's connecting that's how it's taking a Stark proof and connecting with the Bitcoin blockchain, right? It's just a.
No, come again.
I'm just trying to understand when you say why this scripting is so defined. Yeah, what is a script? What is a script?
Perfect. So Bitcoin is written in a low-level programming language. Remember I talked about 3 layers: high level, low level, and then the binary code, right? Now it's written in a low-level programming language. Starknet, whereas Starknet Stark proofs written in high-level programming language. Now let's say this person speaks English, but this person speaks French. They're not able to communicate with each other. That's why you need scripting. With OpCat, what is happening is we are able to immediate the barrier where this person learns French and talks with them is becoming easier because this person decided to help this person with a French dictionary or whatever, right? But since this person is not deciding to help us anymore and the core developers of Bitcoin are not upgrading the protocol.
And one second, they did that as a security protocol, I'm sure, right? As to why.
In 2010. In 2010.
But the reason one would not keep OpScript open is because it's trade-off of security, right? That's the broader rationale.
So here's the thing. Satoshi disabled it to as a security measure.
Right.
But on Bitcoin, right? When something needs to improve, when you have an improvement proposal, they actually have a governance model in place. Where if let's say you SAS, this thinks OpCat is a good way, right, to implement that should be added to the original, the real live protocol we're talking about. What would you do? Write a paper, submit it as a proposal. So Bitcoin improvement proposals are a real thing on the governance of Bitcoin blockchain, and the latest improvement proposal that's the most that's gaining the most attention right now is adding opcat, right? But the problem is it's been gaining attention for like over 4 years now, right?
Yeah.
What?
Like, Bitcoin is not written in low level. Bitcoin is written in C++. The opcat is kind of like low level language.
Bitcoin script, right? That's what I'm saying. Bitcoin script.
So opcat is like one of the opcodes. So those are like assembly in Bitcoin. Inside.
So, not to confuse them, that's the reason I said it's the low level language that it's written in. And to
The Bitcoin.
the protocol is written in C++ is what he's trying to say. But
which is a low level language.
no, C++ is a high level language. That
Assembly would be low level.
Assembly is low.
assembly is the low level language, and opcat is in assembly.
It's in the league of assembly.
What is, sorry?
Opcat.
Opcat, I see.
Opcat allows you to go
So, to achieve Bitcoin script or the assembly language that we're talking about, developers, like the core developers, they write it in C++. You have to achieve it because as humans writing assembly language, you will find very less people that can actually write assembly language.
Okay, I'm heading to the washroom, but I have
Right.
a question. What are the core developers?
What are the core
Who are
developers?
the, I mean, not who are the core developers, what are core developers to Bitcoin? If I were to ask you, I know Haladi will ask. So there's always six
Yeah.
core developers that are constantly changing, that keep rewriting Bitcoin in various forms and
Only
bits
six?
and, yeah.
No,
Yeah, only.
There are usually an average of six.
I
Four?
mean, like those are the.
But they're unknown, right? They're core
No, no,
developers.
no, they are
No, they are known.
They're known.
They're very known.
Peter Todd used to be part of all of us. Peter Todd versus Vitalik, we have a video. He was, that magazine said he's Satoshi bullshit. What I'm saying is they keep
Greg Wright
changing.
is Satoshi.
Yeah, not, anyway, so if they keep changing, the point is even the core developers can do
I
what they
love how
want.
he circles
Okay?
back to
They can do what they
Satoshi.
want. They can rewrite it how they want. When they release the newest version, unless 51% of the miners all say yay, that new fork, it's a soft fork, is not accepted.
Plus, you
So
should read
no one-
Hijacking Bitcoin so you would know
Very
how.
difficult to hijack Bitcoin. I'm
Yeah,
just
you
saying.
should read Hijacking
I will.
Bitcoin so you would know
I
how
will.
unlikely.
Can we take a 2-minute break? I can't run the
Yes.
bathroom till yet. Then
Yes.
I'll quit. Do a moment.
Yes. Go ahead. We're gonna end the live because I think they told me like don't record the breaks.
Oh, it's being recorded, it's coming there? That's
Yeah.
it's